Yes, hello all together. We are
Hello.
happy. Hello, yeah. We are happy to join that you're joining our webinar regarding optimization of global SCM operations. What we want to tell you today in our webinar is how to improve the SAP EWM with AI. This means to increase, to make it better. It means what is the smarter warehousing meaning for you? Because if I look to the name smarter, smarter means also intelligent. And intelligent is based on data. So how can we have an improvement of the EWM, so your warehousing, with the use of AI and data? So because this means you will have faster decisions, you can scale better, so you can scale your supply chain. And this is a thing we will tell you in this webinar. So maybe if Tukaram, you will go to the next slide. Um, I wanted to introduce a little bit about Lognow, but first, before I will introduce Lognow, I will introduce myself. My name is Carsten Weber. I am the managing director of Lognow in Germany. And what we want to tell you is how to bring these two topics, the SAP topic and also the artificial intelligence together. If you see in the header, SAP knows the core. This also means it knows the processes, how all the processes are running, working. But if you use AI, so as I told before, AI means data-driven intelligence. So the AI knows the future. And we as Lognow, we know both together. So you can tell us as a boutique consultancy company or boutique partner for you who can do both. Both means the SAP and the AI topic. And we can also deliver both of these two topics. So let me go a little bit into depth regarding SAP knowledge. We are having a lot of experienced SAP consultants, around about 20 years of SAP experience, especially in the supply chain excellence topic. This means SAP transportation management, extended warehouse management, logistics, production, quality management, and so on. We are also knowing a lot about platform business, including cloud. So for example, things like application management or SAP ECS, the complete operating environment. And yes, regarding, you see, 20 years of experience, this also means we don't have a long setup for a project. So I will tell it like a senior governance. So we are having a structured delivery from Germany and also from India without a learning curve. We can start immediately with you and your projects. And if I go to the right side, to the AI intelligence, our focus and also the focus of our customers is often very strong based on AI, the artificial intelligence first and first by design. This means we build it from the start, no retrofit. So we bring both worlds, the SAP and the AI world, together. So we need to know exactly together with you what is the compliant, the scalable, the secure architecture to build AI processes. The next thing is that all the processes, all the use cases we build together with you are all measurable. So all of them have a measurable impact. So we go from a use case directly to a scalable business impact. And this is very important for us. And also my colleague Tukaram will show it later on, how you can bring these two worlds together, how you go to efficiency. Yeah, that's very important to understand. And the last thing I put on this slide is we can go in the next step also to AI as a service. So not only bring the financials as a service for our companies, we can make this AI with intelligent, based on data. We can help you to bring this to an own service. This means we can assess with you the use cases, what are the relevant use cases. In the next step, we can go into the design with a concept. What is the solution architecture that you can use these tools in a live way? We can deploy it, including the go live of these AI tools, and then the complete operation as an SAP, the application management to run and to help you to grow with the SAP business. We can also do it in the AI topic. And what does it now especially mean for AI and the extended warehouse management? I will hand over to Tukaram, my colleague. He will also make a short introduction of himself. So Tukaram, it's up to you. You can start. Go on, please.
Thank you so much, Carsten. I hope I'm audible to everyone.
Yes, you are
Okay,
audible.
so thank you so much, Carsten. So let's move. So, hi everyone. Good morning, good afternoon, and welcome here. My name is Tukaram Kadam. I'm Director of SAP and AI Business Transformation at Lognow, and I'm really genuinely delighted to have all of you here with us today. So let's begin with the topic what mentioned by Carsten that about AI. So here on screen you can see that how AI enhances slotting optimization in warehouses. So today we are going to talk about two use cases, and one of the use cases is about slotting. So let's start with the discussion for the topic. So what is slotting with WMS means warehouse management system. So in layman term, process of organizing inventory to optimize storage space and picking efficiency. That is nothing but a slotting. And with AI enhanced slotting optimization, this is one of the most immediately impactful application of artificial intelligence in supply chain operations. And though it is impactful, yet I will say it is also one of the most consistently underestimated application. Most warehouses are still running on static rules that were designed years ago, and every single day that cost them lot of money. So in first segment, we are going to break down exactly why exactly this traditional static slotting is costing money, and we'll try to discuss what exact changes AI has made to all these operations of slotting. So let's start with the discussion in detail. I will move to the next slide. So here is the roadmap for today's discussion. There are five tightly connected topics that build on each other. We start with the problem statement first. So what is the static slotting doing to your operations right now? And why traditional methods simply cannot keep pace with modern demand patterns. So from there, we will go to, we'll try to understand the inside the engine, the core AI mechanism, how it works, and how AI mechanism that make dynamic slotting possible. Then we'll touch base on machine learning models, data ingestion pipelines, real-time feedback loops, how it is being configured. Then we get quantitative. We'll discuss about key benefits and KPIs. Actually, these are not estimates, but the measured one and actual scenarios we'll try to discuss here. And while discussing this KPI, we'll touch base on some parameters like travel distance reduction, throughput improvement, space utilization, peak accuracy, all with specific benchmarks. So all these terminologies are from a warehouse management system. So those who are working on this may be aware about these terminologies. So we will then look at two compelling real case studies also. We are going to discuss about it. And during these case studies, you will come to know that these results, what we are talking, are actually achieved. And we close this segment with a discussion on SAP EWM integration, how exactly at the backend system got integrated with AI, and how to connect with AI slotting to your existing warehouse management system. So this is going to be a practical implementation oriented session. So let's start this discussion and let's get into it. So as I mentioned, we'll start with the problem statement where we will try to understand the traditional static slotting, why it is having issues. So let me put these three numbers on the table, and I want you all to sit with them for a moment. So 30% of travel wasted. So, and then peak paths that are 2 to 3 times longer than they need to be, and 60% of warehouse zones with mismatched SKU density. So these aren't edge cases. These are average from high velocity warehouses environment running traditional rule based slotting systems. Systems where fast moving SKU actually end up in back zones, where seasonal shifts are addressed weeks after demand has already changed, where pickers walk unnecessary distances on every single order wave, every single shift, every single day. So these are the these are accumulated with all the problem statements. So the core issue with static slotting is structural. So because it built on fixed rules and periodic reviews, whereas the warehouse world has already changed fundamentally, such as what order volumes are more volatile, SKU profilation is accelerating, customer expectations for fulfillment speed leave no margin for inefficiency. So static slotting was designed for a world that is no longer exists now. And the cost of that mismatch compounds every day, it goes unaddressed. So these are the problem we have with static slotting. So now, how to address it? How AI optimizes slotting? Or maybe there may be a question that what does AI actually do differently? The very simple answer here is continuous intelligence. Where a traditional static slotting system assign a SKU, that is SKU is nothing but stock keeping unit, to a slot and revisits the decision quarterly or maybe never. It assigns SKU to the slot and it may do not revisit the performance of it. Whereas in case of AI driven slotting engine is constantly ingesting data, sales velocity, inventory turnover, order frequency, seasonal trends, external signals like weather forecast and promotional calendars. So this is getting constantly ingested with the data with the help of AI. From this continuous data stream, the engine identifies pattern that no human planner could practically process at scale. So it predicts which SKUs will surge, which will slow, which and reposition them proactively before and well in advance, uh, before the demand shift materializes on warehouse floor. The architecture of this process has three phases, as you can see on your screen: data ingestion, predictive analysis, and dynamic adjustment. And critically, this is a loop, not a one-time event. The system re-optimizes as conditions change. Slotting decisions are never stale, and the efficiency gains compound over time because the model learns continuously from operational outcomes. So this is the key. The AI driven slotting engine is constantly ingesting data and it constantly evolving itself. Based on that, it takes the decisions and which makes a difference. Let's move to the next one. So this slide explain about what the AI engine analyzes, what exactly it does at the back end. So let me be specific about what the AI is actually looking at. First, sales velocity. The system tracks exactly how fast each SKU moves and uses that to ensure your fastest movers occupy what you will you will call as a golden zone. What exactly golden zone? The slots closest to your pack station. It's called as a golden zone, and dispatch areas. Pack station and dispatch areas. Whatever slot is the closest one, that is called as a golden zone. So this has been calculated by AI. So it is simple in concept, but the continuous recalculation at SKU level is what makes the difference. Second, inventory patterns, replenishment cycles, case pack ratios, physical dimensions. The AI matches each SKU not just to a zone, but to the right slot, uh, uh, to the right slot type and size. Third one, uh, and this is one I found particularly compelling: seasonal demand anticipation. The system doesn't react to any festival particularly. It prepares for it weeks in advance, repositioning high velocity SKUs across regional platform to the fulfillment networks before surge arrives. It since it is using the 18 plus months data, it actually able to predict and be prepared in advance. So that proactive posture is simply not achievable with manual planning cycles. So with manual planning, this cannot be predictable, or we cannot be ready in advance for this. So, and the fourth one is peak path affinity. The engine groups frequently co-ordered items in adjacent slot, which means each order wave covers less ground. The travel reduction per wave is modest. Across thousands of waves per week, it becomes transformational. So this is the way AI engine actually analyzes at the back end. Let's move to the next slide. So this is one slide where I will request everyone to take a screenshot, because this is the business case in one view, and these are the parameters we are going to evaluate on. So let me walk through the metrics. Um, Travel distance cut by 10 to 20%. That means lower labor cost and faster cycle times every shift without adding head count. So it's a saving. Then next one is very special one: throughput, up to 40% increase. 40%, that is not a small number. That's the difference between needing a second shift and maximizing an existing one. So we just before this point we discussed about the shift. So if there is an increase of 40% in throughput, there is actually a opportunity to discuss if we really need a second shift, or we can maximize outcome within one shift only. So it's direct saving. So space utilization is the third one. It improves by 15 to 25%, which means your defer capital intensive warehouse expansion decision. You may you make your existing footprint work harder. Means like if there is a proper space utilization, it can impact on a decision of expansion also, because the existing unit is delivering what is expected. So this plays a very vital role from cost point of view. Fourth one, peak accuracy reaches 99% and above. So fewer returns, less rework, and meaningfully safer working environment for your warehouse teams. And labor productivity gained by 12 to 18%, which means it translates directly into better headcount planning and reduce overtime cost. So here's the key insight I want to leave you with on this slide. These benefits compound when you simultaneously reduce travel, you boost throughput, and improve accuracy. The aggregate impact on total warehouse operating cost can reach by approximate 15 to 30% reduction with the first year of deployment. That is a compelling return by any standard. So I hope you understood the key benefits and the kind of deliverables we are going to achieve with the help of AI here. So let's move to the next one. So before and after the number specs. So here you can see easily the bars which are marked in dark blue are before, and then light blue is after one with the AI optimized one. So what you are looking at here is transformation from baseline manual operations to index at 100 to the means against AI optimized performance across every major warehouse KPI. This isn't a projection or a vendor claim actually, but these are the figures aggregated from MHI, Gartner Supply Chain, and Logistic QI surveys. These are the benchmarks covering 2024-2025 implementations. So these are the actual numbers. So every single metric improves, and in notice where the most dramatic uplift occurs. Please notice it. It's throughput. That's because AI slotting doesn't just reduce travel, it reconfigures the entire flow of work through the warehouse. Faster peak cycle creates a multiplier effect across the whole operation. For those of you managing warehouses right now, I would encourage you to think about where your own operations sit relevant or relative to these parameters or these baselines. The gap between manual and AI optimized is not closing on its own. It's like you can realize if you compare the benchmarks with your existing warehouses. Let's move to the next point. So real world case studies, as we discussed that we are going to discuss about the real world case studies on slotting. So I want to spend next few minutes on real world evidences because this is where theory becomes proof. So AI powered slotting is not a concept we are introducing today for the first time. Means this is not the first time we are going to discuss. It is already there in market. There are many leading organizations have already deployed it, validated the returns, and scaled across their operations. So this is already there deployed in the market, and it is getting evolved day by day. So what follows are two of the most instructive examples I have seen. Different warehouse models, different implementation approaches, but remarkably consistent in one thing, that is measurable rapid ROI. So let's look at the both and we'll understand it in detail. So two case studies here, two very different implementations. Both demonstrate what's possible when AI slotting is deployed with precision. First one is Logua AI integration. So Lognow deployed their AI slotting engine across 3 DTC fulfillment center. DTC is direct to consumer fulfillment center. The system analyzed 18 plus months of historical order data and dynamically repositioned over 12,000 SKUs. Within 90 days of go live, reduction in operating cost by 25% as a result. Faster peak times by 35%, and order accuracy, this is the special one, 99.2%. I want to highlight that third number again, 99.2% accuracy in 90 days. So that's not a 12-month maturation. That's rapid value realization actually. 99.2 order accuracy in 3 months. So this is first case, and the other one is about spare. So the spare case is equally instructive, but a different via a different angle. Their focus was specifically on pick path sequencing combined with slot reassignment, and it is deployed in a 200K square feet facility, a huge one. The result, 22% reduction in average picker travel, 38% throughput increase, and a payback period of under 4 months. That's incredible. The ongoing savings of $1.2 million annually. So that's we call as a saving. So think about that water movement, uh, under 4 months to break even $1.2 million in recurring annual savings. That isn't a speculation, it's a reality. This is documented, operational, and actually a reality with Spare. So you can see these two cases and you will understand the importance, means the kind of difference AI is making nowadays in the actual operations. So let's try to understand it more deeply with next slide. So let's look at the exact where the savings originate in each case, because the distribution of value is an instructive as the total. In the case of Lognow implementation, the largest single driver of saving was labor reduction by 40%. So 40% of the total benefit. Fewer errors and return contributed 25%, space utilization accounted by 20%, and deferred capital expenditure. The warehouse, they didn't have to build. So the last one, as we discussed earlier also, it really matters a lot, because instead of going with the expansion of warehouse, with existing warehouse they can fulfill the requirement. And this last warehouse which they didn't have to build contributed by 15%. Now look at the spare one. The picture is slightly different here. Travel distance reduction laid at 35%, followed by throughput gain at 30%, labor production at 20%, and reduced overtime cost at 15%. The common thread across both labor and travel optimizations are the primary value drivers here. Labor in case of Lognow and travel optimization in case of Spare. And this makes intuitive sense because labor represents your largest variable cost and travel time is the largest source of labor inefficiency in a warehouse environment. So both are interrelated. The secondary benefits, accuracy improvement, deferred capex are real and addictive. But the primary thesis is simple. Get your people walking less, pick more accurately, and doing more per hour. So AI slotting delivers exactly that. And that's why it is very much effective compared to the traditional way of slotting. So let's try to understand how it actually reacts with SAP EWM system, means how it is getting configured. So for those who of you operating SAP EWM environments, and I know many of you are, the natural question at this point is, this sounds compelling, but what does integration actually look like? How to integrate it? The answer is more straightforward than most people expect. AI slotting does not require any rip and replace of your warehouse management system. So modern AI agent integrates via standard APIs and SAP BTP, the business technology platform, creating a seamless data loop between your SAP EWM system and the optimization engine. All integration points are built on SAP native standard. So this is very important. All integration points are built on SAP native standard. It uses interfaces like RFC, OData, and the BTP integration suite. This means full compatibility with your existing EWM landscape, your IT governance framework, and your security and data requirements. So it's a native. There is no customization. There is no third-party tool is involved here. So this is not a shadow system actually. This is not a shadow system running alongside your warehouse management system. In fact, it is a tightly coupled, architecturally sound integration that enhances what you already have. So there is no need of any third party here within your system, within available capability. We can do this integration and achieve these results. It is very much possible with AI. So let me go more deeper and understand this integration in detail. How AI connects to your SAP EWM landscape. So let me walk you through the 4-step integration loop. Step 1, data extraction. Real-time inventory movements. It includes means what kind of extraction? Real-time inventory movements, good receipts, picking confirmation, and storage bin utilization data are pushed from SAP EWM via RFC and OData API to AI layer. So we just talk about this, means all the data like real-time inventory movements, good receipts, picking confirmation, all the data lies with your EWM system, S4HANA system. It is getting pushed to the BTP layer, and from BTP layer, it is getting pushed to the AI slotting engine. So that's it for step. Step 2, AI processing. So this is the step 2, AI processing. The machine learning, it has a machine learning engine which ingests this operational data, whatever data is coming from S4HANA system, uh, alongside external demand signals. These external demand signals consist of order forecast, promotional calendars, market data. So with the help of machine learning, it applies predictive models and generates optimized slot assignment for every SKU and storage type in your network. So this is what happens at step 2. At step 3, which is slot update push, those optimized assignments are written back to SAP EWM. So if you refer to the earlier image, so those optimized assignments, whatever assignments are processed by AI engine, are being pushed back to the SAP EWM system. And where exactly it pushed back, it goes directly into storage bin master data and activity area configuration. Now, activity area configuration, those who are working on EWM system, you must be aware about this terminology. So this optimized assignment from the AI system push back to the SAP EWM system, and it directly goes into the storage bin master data and activity area configurations. The system then triggers warehouse task resequencing automatically. So from activity area configuration, what SAP system does, it triggers warehouse task resequencing automatically. Your picker receives updated route without any manual intervention. So this is what is happen at step 3 and step 4. So this is about a performance feedback. So this is what makes it a true self-improving system with AI. So actual peak times, travel distance, and error rates flow back to the AI model, which uses that operational data to refine its next round of predictions. So every cycle, the system gets smarter. Every cycle, the optimization get higher. So it keep on evolving itself, and overall it improves the efficiency. So this is the way. These are the 4 steps what we discuss. How actually AI react, or AI processes a data which as an input, whatever data they receive from SAP system, and then how it loop back to SAP system with the trigger points. So this is the way it keep on going. I mean, this loop is keep on evolving, and hence efficiency improves. So So till now, we have covered the data, the AI mechanisms, the case studies, and the architecture along with SAP. So let me close this segment of first use case, which is just slotting, with the practical path forward. Because the most common question I get after such kind of sessions is like, how do we actually start with? The answer is a 3-stage approach. First is assess. We means like Lognow. Lognow will help you for this. We audit your current slotting performance, map your data landscapes, and benchmark your operations against AI-enabled performance targets. That gives you a clear view of your specific opportunity, and it's not a generic benchmark, but the specific whatever parameters we are going to check, we will recommend on those parameters. The second step is pilot phase. We deploy in one zone or one warehouse for you. The goal is to validate ROI in 90 days, and not a proof of concept, which actually proof of concept gets disappear very early, but it will be actually a live deployment that generates real data, real saving, and business case for full rollout. So we'll start with one warehouse, and then we can scale it to the other warehouses, whatever you have. So third step will be, once the pilot has validated the model, we extend across your SAP EWM landscape with full API integration, systematically with minimum disruptions to the operations. The data is clear. That is the prerequisite. Data needs to be clear. The technology is proven. The payback is measured in weeks. If you want to explore that, what this looks like for your specific operations, I would encourage you to reach out to a personalized ROI assessment. Our team will help you with this. Our team will build you a business case grounded in your actual numbers. So anyone who is interested, please, at the end of this session, I will share contact details, and you can reach out, and with these 3 steps, we can assist you with the complete transformation of your warehouse processes. Okay, now with this, I will move to the next case study, that is predictive labor planning. So let's now move into the second major topic of today's session, predictive labor planning. And I want to open with a case study here because it illustrates the problem better than any statistics I could quote. This is a third-party logistic provider. It has multiple client accounts, complex structure, variable workloads that shift by client, by season, by day of week, and a chronic problem that many 3PL will recognize. So alternating between the chronic problem will be like alternating between overstuffing and understaffing, with no reliable way to predict which one was coming next. So this is a very traditional problem case or problem we have with labor management. So the consequences were exactly what you would expect with this overstaffing or understaffing is missed SLAs when they were understaffed, or excessive overtime when they overcorrected, and management operating in permanently reactive mode here with labor management, responding to yesterday's numbers, not planning for tomorrow's demand. This is the exact problem with labor management. The solution deployed here is integrating historical SAP EWM data with AI powered seasonal models, enabling the system to predict daily labor demand with precision. With 6 months, the observation and result is 15% labor cost reduction, improved SLA adherence across all accounts, and the complete elimination of reactive last minute staffing decision. This is completely reduced, completely eliminated last moment decisions, because there is a very good proactive approach along with the data. So uh, we'll discuss in detail about this topic with next slide. So before we go deeper into the AI layer, let me ground us in what SAP EWM labor planning actually encompasses. So uh, at its core, SAP EWM labor planning is the strategic process of forecasting. It's a it's a strategic process for EWM of forecasting, allocating, optimizing warehouse labor resources, connecting workforce decisions directly to execute data. This is the main problem, that connecting means without uh, understanding connecting workforce decisions directly to the execution data. So that last part is very much crucial. This is not a separate planning system. It's embedded in the same platform where warehouse tasks are created, assigned, and confirmed within SAP EWM system. So four capabilities defined it. You can see on your screen. Demand forecasting. This analyzing inbound orders, outbound shipments, historical workload data to predict labor demand accurately and proactively. Second one is intelligence task assignment. So matching tasks to the right workers based on skill set, certification, location, availability. Real-time performance monitoring is the third one. Tracking individual and team productivity against engineered standards, flagging deviations the moment they occur, so supervisor can act on it. And labor cost and efficiency analysis, the fourth one, giving you visibility in cost per order line, per zone, per shift, enabling continuous improvement grounded in real data. So these four capabilities working together make SAP EWM one of the most powerful platform available for warehouse workforce management. So we all, those who are working, you all must be aware about these features of SAP EWM. Let's move to the next one, and let's move back to our actual problem statement of labor planning. So let me put the business case in stark terms here. So labor represents between 50 to 70% of total warehouse operating cost. It's a huge one. That is the single largest cost lever in your operation, 50 to 70%, which means that improving labor efficiency is by definition your highest impact operational priority. So if we have to improve on anything, we need to look at this, the most contributing factor in the cost. So the second number on the on this slide is equally important actually. The SAP EWM reduces shift planning time by 2x compared to manual spreadsheet based methods. That's not just an efficiency gain for planner. It means decisions are made faster with better data in advance in planning horizon. The strategic insight here is one I want to be explicit about. Uh, SAP EWM labor planning operates on two time scales simultaneously. In one is short term, where it supports daily shift planning, right sizing your workforce for tomorrow's orders, and in long term, it enables strategic headcount modeling, seasonal ramp ups, network expansion, workforce investment decisions. That dual capacity, operational and strategic, integrated in one platform, is what makes it indispensable for any warehouse operating at scale and speed. So means this dual capabilities are there with SAP EWM system, which makes a lot of difference to the actual operations. So let's try to address where exactly what is the issue with the labor planning here. So one of the most persistent problem in warehouse operation is the disconnect between workforce planning and execution. HR system actually operates in one world, workforce management tool operates in other world, and on top of it, the warehouse management system is in third world. So data moves between them manually with all the delays, errors, and blind spots that implies to the problem statement. So with SAP EWM, it eliminates that structural problem by embedding labor planning directly into the execution platform. Warehouse managers gain a single integrated system that connects workforce decisions with real-time operational reality. The right person is assigned to the right task in the right zone at the right time. So, not because the supervisor made a good call at shift start, but because the system is continuously aligning workforce capacity with actual work demand. This unified approach creates something that is genuinely difficult to achieve through manual coordination. It is actually impossible to achieve with manual coordination. A single source of truth for every labor decision made on the warehouse floor is data integrity is the foundation for everything that AI layer built on top. So we while we were discussing about the architecture diagram, we talk about data integrity, the data which comes from SAP system that needs to be integrated correctly with correct tools so that it will act as a foundation when we are going to apply a AI layer on top of it. So let's discuss about it in next slide about AI. So AI driven SAP EWM predictive labor planning. So as we discussed in earlier slide, we have established the foundation, what SAP EWM layer planning does. We discussed about SAP EWM labor planning and why it matters at a business level. How exactly SAP EWM helps business uh, for to manage all this labor plannings. So now let's take it to the next level because the real transformation happens when your AI layer on top of it that integrated with the platform. So predictive labor planning with AI doesn't just tell you how many people you need tomorrow morning, but it actually tells you with 92 to 95% accuracy how many people you need at what time. So that's the biggest difference. Not only at what time, but in which zone, with which skill set profiles for the next 6 weeks. Not only for tomorrow, but for next 6 weeks, it can provide all these such granular details. And it generates that forecast automatically, continuously, and with full integration back into your EWM task management system. So as we discuss about that back loop, so whatever analysis it does at AI layer, it pushes back to the as an input to the SAP system. So this is the shift from reactive to genuinely predictive operations. So let me show you exactly how the system works. So here we will try to understand the labor planning challenge in modern warehousing. So I want to take a moment to conceptualize the labor challenge specifically for European operation colleagues. So because the number here are striking, for example, Germany's warehouse labor bill exceeds France and Italy combined. So Europe average hourly rates have reached approximate around 30.5 euros, with euro rate area rates at 34.30 euros. The labor cost index has climbed by 25 to 27% above the 2022 baseline, and worker turnover is running at approximately 30%. A persistent drain on recruitment, onboarding, and training investment, these are the side effects of it. So, for European supply chain leaders, these are not marginal pressures. That is a structural cost. That is a structural cost challenge that will only intensify. So, and as a result, automation investment cases are strengthening quarter on quarter. So everyone wants automation for this. So not because automation is a fashionable idea, but because the economics are becoming impossible to ignore. In this environment, AI driven predictive labor planning is not a luxury, it is a competitive necessity. So there is no alternate to the AI if we really want to address this issue. We'll try to understand it in more depth with the next slide. So these four metric defines the static landscape that AI labor planning must navigate. Euros 30.5 EU average hourly cost rising year on year. Euros 34.30 in the euro area driven by Western European wage premiums. A labor cost index increased by 25 to 27%, which is above 2022 baseline, and a 30% turnover rate that compounds recruitment and training cost continuously. So it overall accumulates huge cost to the operations. The strategic implication here is direct. When labor represents up to 70% of your operating cost in a high wage region, and you are simultaneously facing rising unit cost and structural workforce instability. You have a dual challenge here: control unit cost while stabilizing retention also, both at the same time. So traditional management tools, manual scheduling, reactive headcount decisions, spreadsheet based planning, these are not calibrated for dual challenges like this. AI does, AI is capable compared to the traditional way. And the evidence for that is in the outcome we are about to discuss. So, how AI powered predictive labor planning works. So, this is very interesting one again. So let me open the hood here and show you the three layer of the AI engine. The first layer is data in integration. The AI ingests historical data from SAP EWM, which comprises with order volumes, SKU complexity, seasonal patterns, actual labor hours, and uses machine learning to identify correlations between order characteristics and resource requirements that are invisible in human planners. It is not possible while we are planning it manually to look at all these parameters. So hidden patterns, non-obvious relationships, cross-variable interactions at a scale no spreadsheet can process this. So, and let's move to the second layer, which is predictive modeling. Advanced forecasting engine produce daily and hourly labor forecast up to 6 weeks in advance. And here is the number I want you to focus on: 92 to 95% accuracy for the 6 week in advance planning forecasting. So across 50 plus variables, including weather impact, promotional events, and carrier schedules. That forecasting precision is what transforms shift planning from educated guesswork into disciplined operational science. And the third layer is automated scheduling. The system generates optimal shift plan automatically, balancing labor cost against service level requirements. And because it's integrated with SAP EWM system, it adjusts those plans in real time as actual workload deviates from the forecast. Human planners make decisions here, the system, but in case of AI, the system executes and adapts it. So this is what it makes a lot of difference. So let's move to the next and try to understand in case of labor planning also, what is the high level architect um, acts at the back end. So the architect has four phases here, forming a closed loop intelligence system built entirely on the SAP technology stack. So there is no third party application required here. So phase one is about source and prepare. Um, so data from S4HANA, EWM, and HR system is harmonized in SAP data sphere into AI ready data set spanning for a duration of 18 months or more months of history. So that historical depth is what gives the models the pattern recognition capability they need. And in phase two, which is train and forecast, so SAP BTP AI core trains pattern recognition model and generate daily and hourly labor forecast with full scenario simulation capability. So what happens to your labor need if a major promotional event overlaps with with peak season? The system can model it before it happens. We already discussed about advanced prediction 6 weeks in advance. So this is how it acts and help to the overall operations. Third one is phase three, um, execute and adjust. So forecasts are pushed via BTP integration suite to EWM for shift planning, workload balancing, real-time adjustment as conditions evolve through the shift. And the fourth one is monitor and act. So here we have a SAP Fiori it comes into a picture. So SAP Fiori dashboard delivers role-based visibility, what the shift supervisor sees, the operations director sees, the HR planner sees, all tailored and actionable with the help of Fiori dashboard. The design principle I want to emphasize here, every component is native to the SAP ecosystem. So there is no third-party tool required. So no third-party middleware, no data sovereignty risk, minimal minimal integration complexity, minimal data fidelity. So everything can configure within SAP ecosystems and it can deliver very high standard results. So this was the high level architect. Let's move to the next one. Now the numbers, measurable business impact, real world. So let's bring this back to what it means in business terms, because architecture is only as valuable as outcome it produces. So we have a very great architecture at the back end, but then it only has a value if it delivers a reliable, measurable, quantifiable outcome. So 18 to 25% labor cost reduction achieved within 6 months through optimized staffing levels and substantially reduced overtime. 18 to 20% labor cost is reduced. We already know that overall labor cost contributes to 70% of our operation cost. So out of that 70%, 18 to 25% labor cost got reduced within 6 months time. It's a very good achievement. For a warehouse running around 500 million euros annually, with a labor bill, means if we have to talk in terms of numbers, suppose a warehouse which has 5 million annual bill for the labors, and if we consider this 18 to 25% labor cost reduction, in numbers actually it is around 900k, between 900k to 1.2 million euros in saving from the same workforce without cutting a single position. So that's a great achievement, great saving. So, and then on top of it, there is 95% forecast accuracy. That is the bedrock of confident planning. When your supervisor trusts the forecast, the plan better. When they plan better, operations run smoother. The next one is 30% uh, onboarding for 30% faster onboarding for new workers, because better visibility means proactive hiring, and proactive hiring means time to productivity is compressed, and 99.2% order fulfillment during peak periods, because right size teams means consistent service level even when demand is at its highest. So everything is interlinked with each other. If we are fixing one thing, it is automatically results on other things also. So all the parameters get influence with each other. So the result from Fortune 500 retailer and 3PL confirms this, that this is already confirmed that ROI achieved within 4 to 7 months. One global distributor saved euros 4.2 million annually while improving customer satisfaction score by 12 points. Operational efficiency and customer experience improving simultaneously. So that is the compounding power of predictive intelligence. With AI, it is possible. This is all reality and no speculation here. So next, very important thing, getting started with AI-driven labor planning. So for those you considering how to move forward, let me give you the practical roadmap. The same three-phase approach we use with every client. We means Lognow. So we can help you to build this. Like phase one assessment, which take 2 to 3 weeks time. We evaluate your current EWM data quality, identify integration requirements, and benchmark your existing labor performance planning against AI-enabled targets. So you leave this phase with a clear picture of your specific opportunity and a quantified business case with numbers. With phase two, it will be pilot implementation. So Lognow team can do this in 8 to 10 weeks time. We deploy the AI solution in a single facility. The goal is to validate the models against your real operational data, refine predictions, and generate the evidence needed for full rollout approval. This is not a sandbox exercise. It's actual. It's a live deployment generating result, real result. So this is with phase two. And with phase three, scale and optimize. So this will be an ongoing thing. Uh, so we roll out across your network, and the system improves with every facility added. More data means richer platforms, richer patterns, which means higher forecast accuracy, which means compounding ROI at every site. A word on success factor here, because implementation quality matters as much as technology quality. So clean historical data spanning over 18 months or more, executive sponsorship, seamless integration with existing EWM workflows, and a commitment to continuous model refining based on actual operational outcomes. So all these things, all these steps, means phase one, phase two, phase three, you can contact Lognow and we will help you to get those right, and the result means everything will be right, in right manner, in right way, and definitely results will follow it. We have already seen the numbers. So with this, I would like to conclude here. So let me bring everything together before we open for questions. Today we have covered two transformational application of AI in warehouse operation, and the evidence is consistent across both. AI slotting optimization delivers 15 to 30% cost reduction, up to 40% throughput uplift, and 99 plus percent peak accuracy, which is integrated with SAP EWM via native APIs. No rip and replace required here, no third party involved. Next, and the other case where we discuss about predictive labor planning, which delivers 18 to 24% labor savings. These are actual numbers, 95% forecast accuracy, and ROI, return on investment, in 4 to 7 months. Build on a scalable, in this case, the example which we discussed was a EU based example, Europe based example. So this was compliant on from architecture point of view to the EU norms. So the thread connecting both of this means both these cases, smarter warehousing is not a future state. It is available, deployed, and delivering result for leading operators today. Already it is there in market. The question here is, the question is not whether to invest. The question is how quickly you want the results or the returns. Lognow is here to help you answer that question with a business case built on your number, your data, and your operators with your operations. So, so I would like to close on this note and open with the Q&A. So I would like to close with AI turns warehouses into a profit center. And please do contact us in case if you are also willing to turn your warehouses into profit center. There is an email address we have mentioned here, hello@lognow, log-now.com. So thank you so much for your time, and we are open for question answers. So I will request my colleague Vivek if there are any questions.
Yeah, so there are some questions into the Q&A session, so that has been answered by our panelists. So thank you for that. And if there are any questions, please feel free to put it into the chat. We'll just wait for a minute for your questions.
Yes, we had around about 10 questions for your information, Tukaram, in the chat. All are answered.
Oh,
So good question. So a good presentation, because I think maybe until somebody has written something into the chat, that's what I started today. The SAP knows the core. You see now the EWM knows the core, the processes, and the
yeah.
AI knows the future. And Lognow brings both worlds or both things together. Yeah, this is also shown very, very, very yeah, impressive by you. Thank you very much.
Thank you. Thank you so much. Thanks everyone for attention and for your precious time.
Yeah.
So,
So
yeah, Vivek,
yeah,
over to you,
yeah.
please.
Just wanted to take a last moment. Thank you everyone for joining us today. We have seen how combining AI with SAP WM can turn warehouse operation from reactive to predictive. As a takeaway, think about where AI can start adding value in your operations. Often a small pilot is all it takes it to begin. We appreciate your time and engagement. Feel free to reach out to us at hello@lognow.com to explore the further activities. With this, thank you everyone for your time.